Hello, everyone. So we're an MLA group. We worked with a company called KnowMeQ, which is a company out of Toronto, on a project where we tried to create an automated prior learning assessment and recognition, and we'll get into what that is. So there are the three of us. There's me and Anemily, there's Debatiya and Zhendong. So we were the three people that were working on this project. So what is prior learning assessment and recognition, which I'm going to call PLAR? That's a mouthful. So it's a mechanism in Ontario where people can use their past life experience. This could be work experience, volunteer experience, like just your experience as maybe a foreign national to get credits outside of the formal like credit transfer mechanisms. So consider there's this person, Alice, who's an accountant. She's heard about PLAR and she wants to get a degree in business. So she gets her portfolio together, which includes her life experiences, such as her resume and transcripts, and she hands that over to Bob, the administrator. And then PLAR happens, or, but it would, but it's slow because currently PLAR is done manually. So that means Bob has to take Alice's profile, give it to all the other administrators and all the departments. Those people cross-reference the learning outcomes in the college courses with Claire's portfolio. They create a list of courses Claire might or Alice might be eligible for through PLAR, and then somebody like a degree coordinator makes a final decision on what courses Alice actually gets. So that's slow. And because it's slow, colleges are disincentivized to offer many courses through PLAR because then every time there's a PLAR request, they have to do a lot of work. So KnowMeQ's goal was to design an automated tool to enhance the PLAR process for students and streamline the PLAR process for colleges. So what we created, like during our internship, were machine learning-based solutions that enhance a user's portfolio, automatically cross-reference using machine learning techniques, the portfolio with the course learning outcomes, provide PLAR recommendations. So these are just recommendations of courses we think the portfolio qualifies for, courses they qualify for. And we leave the final decision of awarding credits to the administrative user. So the college still gets to decide whether Alice gets the credits or not. So a semi-automated, because that's what it is, PLAR process has many benefits, like colleges can streamline degrees and increase enrollment because they can put all new students through PLAR. That hopefully encourages them to make more courses available for PLAR. And that, again, would hopefully promote education equality by increasing the number of people, like more Alice's, requesting PLAR. And then one of my associates is going to go over sort of the data sets we used for this project. If they're here. You're muted, Zhendong.
Yeah. So our first data set comprises approximately 2 million LinkedIn profiles from Ontario, Canada. We aim to extract user experience, which include job and educational backgrounds, to understand the professional landscape. This is the input data of our PLAR system. Each profile will be analyzed to identify the different experiences of user, conceptualized as smiling face linked to multiple rectangles representing their diverse experiences. And the ONET dataset provides a comprehensive view of necessary skills for about 1,000 jobs based on extensive surveys in the United States. This rich source of information will be instrumental in identifying key skills associated with various jobs. We envision each job within ONET as a node connecting to its skills, forming a network of job skill relationships. Similar with ONET dataset is our education dataset, focusing on academic backgrounds. We analyze approximately 50 academic fields sourced from Wikipedia to determine the skills typically gained from each educational experience. Similar to ONET, this data help us to predict the skills we can expect from individuals based on their self-claimed educational background, but different from ONET, which is gathered from survey. We get this information from ChatGPT-4 We first get around the 50 academic fields from Wikipedia, then we fetch learning outcome from GPT-4. Our course description dataset is from 5 Ontario colleges and are used to make recommendation on. This involves a process of converting course description from PDF to text format and organize the extracted learning outcome into a structured JSON format. Given the variability in course description formats across different institutions, we have developed a generic approach for learning outcome extraction based on prompt engineering with ChatGPT-4. So our PLAR system is defined based on these data sets, and we will explain later in the methodology section. Thank you.
Yeah, so this is sort of how those data sets relate to our methodology at a high level. You can see sort of the input is LinkedIn, and then task 1 is job education normalization, which is sort of that enhancement we were talking about before. And then the next step, as you're moving down the graph, are matching the enhanced profile with the learning outcomes. And finally, we end up with the course recommendations at the bottom of this sort of graph. So as you can see from the previous, we sort of split things into 4 tasks: job normalization, course recommendation, course learning outcome extraction, and this was added late in the project, education normalization, which is, so tasks, so 1 and 4 here are the enhancement. Number 2 is the recommendation. And number 3, we sort of already described how we did it. We use prompt engineering to extract learning outcomes. We're not going to go into it much more than that. So for our data sets, we have sort of 2 domains. We have the job domain and the education domain. And we don't have any labeled data. You didn't hear anything about labeled data in the previous section. And so a lot of our machine learning tasks were trying to find ways to align these 2 domains, because internally, LinkedIn and ONET are easy to compare, and sort of college learning outcomes and degree learning outcomes are easy to compare. But like, how do you compare these 2 disparate domains without any labeled data? So we're talking about the portfolio normalization, so I'm just going to lump together job and education normalization. So Alice uses our tool. She gives her regular portfolio, which has a job in it called financial analyst, which has this description. Our tool provides Alice with a list of the top 5 jobs from ONET that are similar to her portfolio, to that degree, and that we or that job, and we give them actual scores. Like, a higher score is a better score. These scores don't really work across jobs; it's per job. So Alice gets to choose the option that best matches their experience. And we'll note that because there is a human in the loop in this decision, there is no lying. She can't choose one that doesn't match her job, because then Bob will see that at the end and say, Alice, you're lying. You don't get any credits. So Alice makes her choice of financial quantitative analysis. Then we take the ONET data and we augment Alice's resume, like specifically that position, with the underlined text, which is the text from ONET. And you can see now there's much more information, and hopefully Alice gets more PLAR courses this way. And it's called normalization because everyone that chooses financial quantitative analysis gets all of those things added to their portfolio. So for course recommendation, our model cross-references things using various machine learning techniques. We'll get into the best one soon, and provides a score for each course. So here you can see a score of 1 means we highly recommend it, and a score of 0 means we weakly recommend it. So she's very likely to get, we think, financial statement analysis, but not likely to get survivor skills for actors in business. So who can see these recommendations? Alice can see these recommendations before she actually tries to start the PLAR process. Maybe she decides it's not worth it. She only gets a couple of courses and it really won't actually help her with her business degree. And Bob gets to see them because this is what Bob is shown on his end of the tool. Bob also gets explanations, Alice can see them too, for these recommendations. So you can actually see, these are the 3 learning outcomes for this financial statement analysis course, how well each individual learning outcome was matched. And also we take Alice's portfolio and we highlight the parts of the portfolio that were used to make the recommendation. So the match scores you saw previously are made using the highlighted text. And you can see only like her initial, 2 things in the ONET data actually helped her to get this course. My associate will go on to the actual machine learning for their best performing model.
So this is the advanced course recommendation pipeline which we use. So this consists of two different models that we fine tune. First is a bi-encoder model specifically for retrieval purposes, and then there is a classification based cross encoder model, we call it re-ranker. So this is a retrieve plus re-rank pipeline. So what happens is you one job title from the candidate's profile comes to the pipeline. It gets passed to the bi-encoder or the retrieval module, and this retrieval module encodes all the courses or like courses in our collection or the database which we are comparing to, and the like embedding of the job title is compared with them, and we retrieve top n candidates, which is for us it is 250. So we retrieve 250 candidates and pass it to the re-ranker model, which is the final model, which gives final scores. So let's say it has a confidence of 90% that this is a correct match, it will give a 0.9 score, like that. And then we like sort the hits or the particular courses for that job title based on this final scores from the re-ranker model. So this is the example of the graphical user interface which we developed for KnowMeQ. If you see, this is the candidate's profile, financial analyst, and there are multiple experiences. So in the right, you are seeing scores for each learning outcome as well as the recommended courses. So if you see, this is a compensation and benefits manager. He has he has 2 courses recommended. He's a physician. He has multiple courses recommended. All of them are relevant, and the scores that are being matched are above 90%. So we set a threshold of 90, which works best for us, and the confidence are super high. And we asked KnowMeQ to analyze these results, and they were happy with all the results from this pipeline. Yeah, coming to how we created a training data. So this was a kind of semi-supervised or self-supervised approach because we didn't have any training data to align both of these domains. So what we did was we took ONET, we took each job in ONET or job title in ONET, and we created this kind of a prompt to GPT 3.5, write abilities of a person doing the job of X or the job title X in such a way that it represents course learning outcomes. So we kind of reverse engineer to create this data set, which is a pseudo data set. So for each for this job title, for example, word processors and typists, we get these bullet point learning outcomes, proficient in using word processing software, or these kind of things. And we call this GPT learning outcomes. And this is how we train our using this data, we train our models. So we have two training for according to the pipeline. So there was a retrieval module of the bi-encoder and the re-ranker model, which was a cross encoder. For the bi-encoder, we use MPNet base v2, and we use multi-negative ranking loss, which is a kind of contrastive loss for training the models. So if you see in the right, we have a job 1. It has multiple tasks. So we take the job 1's title and compare it with each of the learning outcomes generated by GPT. So we create positive pairs and negative pairs in this way. And when we train this on the pseudo data set, we get a 0.99 top 1 F1 score. This was for the retrieval, and then we trained a fine-tuned contriever using this data set, but with balanced negative. So we uniformly sampled from each job equal number of positives and negatives, and we trained using binary cross entropy. And this was our main model, which was giving the final scores for our recommendations. So yeah, this was the results from the using the pre-trained versions of the model instead of the fine-tuned versions of us. So if you see, this is one course and the consequent learning outcomes. So for all the learning outcomes, the confidence is super low. So it's like 0.67, 0.51, like that. But these are the top ones. So but the company actually wants that our model is super confident while making predictions. So if you see the advanced pipeline which we trained, it gives us super high confidence, and only those are having high confidence which are relevant mostly. So if you see at the end, it goes slightly down. So for example, in SCM 220, there is a 0.8, it drops to 0.86 suddenly for one learning outcome. And once you go down and down, it will keep on getting down and down. So yeah.
Sorry, I was muted. As you heard a lot there, as my associate was talking, it was the company was happy with the results. So again, we don't have any label data. We can't do an accuracy score. We can't do an F1 score for like the actual true final product. It's a subjective evaluation of the results. So one of the things we learned, it's hard to work on classification tasks with no label data, and there's no substitute for domain expertise. So the company actually plans on continuing with this project after we're done next week, and they already have plans to bring in PLAR experts to actually evaluate the decisions we're making. We did manage to build solutions with pseudo data and self-learning. So pseudo data is the one we talked about previously. Self-learning was another method that worked, but we weren't sure we'd have time to talk about in this presentation, so it got cut. And as interns in the MLA or MLAs, I don't know what our official title is, it was great to have feedback from experts at Vector. They made sure we didn't overcommit. That was the feedback we got mostly when we were starting the project, is you're committing to too much at the beginning, dial it back and leave things for stretch goals. And also that we had a lot of great feedback from like machine learning experts who provided their expertise when we were trying new methodologies. We also have some recommendations and future work for this. So this is a thing we've been talking about with KnowMeQ from the very beginning: create label data. And you can do this by monitoring the users. So Bob gets a bunch of PLAR recommendations from our tool. Bob makes decisions on them. We record those decisions and turn them into a training data set, and we retrain our model. And typically when this happens in other like real life experiences, the model gets quite a lot better. Also, this is just a thing you should be doing in general. If you all of a sudden start like working with more colleges, maybe you work with 5 to start and you work with 10, there might be domain drift because of the specific way they like phrase things, or the specific way they've got like templates for their learning outcomes. Continuous training allows your model to like adjust to that drift as it happens. Another thing we saw is like based on the results of self-learning is few-shot learning, which is like few-shot prompting, but instead of getting like Bob to make these decisions, we get the PLAR expert to give us a set of labeled data, 100 examples, 200 examples at the sentence course learning outcome level. And then we could either just train on the few-shot examples, or maybe we can use it as part of the self-learning algorithm. And another thing we didn't have time to try is we've got several models that have decent subjective results. So a way to combine, moderate, predictors into a strong predictor is ensembling. So if Alice gives us her portfolio and 2 out of the 3 models were ensembling, vote yes, she gets it. Otherwise, she doesn't get it. As a recommendation for our system. Yeah, so I think we're a little early, but I think we're done. And are there any questions?
Hey, amazing job. That was really interesting, really well put together. So great job. Big round of applause. If we were in the room, you'd get a big round of applause. So our judges, please go ahead and ask questions, comments, anything at all.
So great presentation. I just had a question kind of out of personal interest. So in terms of the PLAR tool in general and the automation of it, I've actually never heard of these types of tools, but it makes a lot of sense. I'm wondering whether the automation of these tools specifically kind of will actually have any hope of bettering the application experiences for marginalized groups, or whether there's evidence of that already happening. Especially given things like special circumstances essays and those types of things rarely have like a significant impact on the admissions process for someone that would be otherwise refused. And I'm just wondering essentially whether it leads to increased uptake of different marginalized groups into the education system or other systems.
Yeah, I don't think we've examined that. I believe the hope is it would, but I do not know that they've done any like studies. Like again, they haven't worked with a PLAR expert before. The motivation for this is I believe the CEO of the company KnowMeQ has worked in the academic field before in colleges. And so he wants to build a tool to do something like that, but whether it will or not, I would suspect though, because like maybe because you would include such a special circumstance letter in your portfolio, our tool would match against it sort of in an agnostic way. It doesn't care where the sentence comes from. And so if there was like a bias in the system against people who are writing those letters, it hopefully would be hidden, maybe, or maybe be washed out. But on the other hand, these models can tend to be biased themselves. And we haven't been able to do a bias analysis just because right now we're still on subjective results, if that makes sense.
Yeah, that's super helpful. Thank you. I also just wanted to ask whether you foresee any like privacy issues or considerations given the data that you would possibly be using, I guess when labeled more so would be a bit of a personal and sensitive nature type of data. And did you include any of those considerations into your work so far?
So for privacy, I obviously when making predictions, like Bob, the academic person, would be seeing all this information anyways. If there was some sort of leak of the model, there is no privacy consideration. So if somebody gets access to the model right now, they could, in practice, probably reverse engineer some people's personal data. The idea is you would never expose the actual model to a user, though. So that's, I believe, when I brought it up with KnowMeQ, they were treating it more as like a security issue. Like, as long as we don't give anyone access to it, it should be fine. I don't know if that's actually true, though, because there may be a way someone can give them a malicious. I brought this up with them, and they didn't. They were like, didn't talk about it, to give like a malicious portfolio to actually have the model make its recommendations in a way that you can extract information. So I did bring that up with them, but right now I don't think they're worried about it. So, but thank you for, yeah.
Thank you so much. That's
Yeah.
all of my questions.
Hey, any other questions or comments from anyone?
Yeah, I just have one like very general question. Like, are there any competing like commercial systems out there that do like achieve what your group was trying to do? And what's the main difference between those existing systems and what you have done?
So as far as the company knows, there's no tool that does this specifically. There are tools, however, that provide upskilling recommendations for companies. So a company can take its employees' portfolios, and it can provide them upskilling recommendations like you should take this course or get this degree. To get this degree, and that will improve your company's what is the word, adaptability quotient. I'm not a person like that, but as far as the company we're working with knows, nobody has done a tool like this specifically to actually work with the colleges for like the PLAR process or similar processes in other provinces. There might be, though, because I was just relying on the company to tell to do that research. So
Thank you.